Hello, everybody. Good morning. We are about to start on part 2 of notes for simplifying radicals. Um, Instead of mushing this all together into one note, I decided to break it apart so your heads wouldn't explode. So today we're going to be investigating perfect cubes, as well as what do we do if we have a variable within our radical. So it's going a little bit more specific than we went in on Tuesday. Okay, perfect cubes. It's very, very similar to square roots, except we're now to the third power. So for example, if I take 3 and raise it to the third power, I would get 27. If I took the cube root of 27, that would bring me back to 3. So it's the same forward and backward motion as squaring and taking the square root. And at the bottom, I have a list of perfect not square roots, perfect cube roots. Now, the previous list we had for square roots, you may not have had to write that down and have it off to the side because you could kind of work your way through the number line. I don't know if it's the same for everyone, but perfect cubes for me can be challenging to remember right off the bat. So typically when I'm doing these types of problems, I have my list of perfect cubes right next to me. You can easily type this into your calculator and find these perfect cubes, but remembering them right off the bat, that's a challenge for me. So if you are the same, you're more than welcome to write these and have these off to the side. Just because when we simplify those radicals, you're going to need to know these. Okay, before we dive into some problems, I want to show you how do you input a cube root into your calculator. You are going to first click the math button. Oh, where is my? Well, un momento, por favor. Let me get my pencil going. There we go. Okay, you are going to click the math button. That will pull up a screen, which I'm pulling it up right now, of all types of different operations. So you can enter a fraction, you can enter a decimal, you can take to the cube, or you can take to the cube root. So you're going to hit math, and you can either scroll down to number 4 on the list, or you can type in number 4. Once you do that, this cube root with a parenthesis sign will pop up on your screen, and then you can type in your radicand. A little tip though, in the future, if you are taking something to the fourth cube, you can change that 3 if once you hit that 4 and this cube root with the parentheses pops up. If you go up to your scroll dial and click the left thing, you can go over and change the little 3 into whatever value you need. Most of the time, you'll just be using the square root and cube root. But however, as you get more advanced, you might need to change that number. So that's how you use that operation. But today, we will just be doing the cube root. So, similar to simplifying radicals for square roots, we are going to practice with the cube root. So, what is the cube root of 8? Did I memorize that? No. I typed it in my calculator, or I had my handy dandy list. So the cube root of 8 is going to equal 2. All right, for example number 2, I have 5 to the cube multiplied by the cube root of 343. Similar as before, my coefficient stays in front and it's multiplied by that radical. So I'm going to take the cube root of 343, type that into my calculator, and I get, what'd I get? I got, I think I messed up my key. Okay, 343, that gives me 7. So 5 times 7 gives me 35. Okay, example 3, I'm going to take the cube root of 27, and that gives me 3. If you want to check yourself, take 3 times 3 times 3, and that equals 27. Okay. And example 4, I'm going to take 2 multiplied by the cube root of 1,000. The cube root of 1,000 is 10. 10 times 10 times 10. When I take 10 times 2, that gives me 20. Okay, so not too shabby. We love perfect cubes and perfect squares, but as always, it's not that nice and pretty. So what happens if we have a non-perfect cube root? We're going to complete the same process as we would a square root. We're going to break it up. So you are going to be making your list. How can I find multiples of 40 to kind of break up this radical into two separate cube roots? And I want to find that perfect cube root so I can get rid of that radical. Remember earlier when I said, hey, it's nice to have those perfect cubes off to the side? This is why. So I make my list of my multiples of 40 that are cube root. I could break that up into 1 and 40, but that's not going to help me. But if I break it up into 8 and 5, well, 8 is a cube root. So I'm going to use those two. I'm going to break it up because if I take the cube root of 8 multiplied by the cube root of 5, that will get me back to my original answer or my original problem. So that's why we're allowed to do this. All right, now it's time to simplify. What is the cube root of 8? Well, that is 2. 2 times 2 times 2 equals 8. And then I'm just going to bring down my cube root of 5 because that does not simplify. So my answer is 2 cube root 5. Okay, let's try another one. Simplify a non-perfect cube root. We have the cube root of 192. Now, that's one I do not memorize off the top of my head. So I clicked through my calculator and I found my perfect cube roots that are multiples of 192. So I took my list I had before and I did 192 divided by 1, 192 divided by 8, 192 divided by 27. In my numbers that are whole numbers, I added them to my list. That's how I know they can be used. So when I went through that process of my perfect cube list, I found that 1, 8, and 64 are multiples of 192. Now remember when, back in square root, I want to find the perfect cube root or perfect square root. That's the largest value that's divisible by my radicand. So here, that would be 64. So I'm going to break up my radicand into 64 and 3. Okay. Cube root of 64 simplifies down to 4. And my 3 cube root 3, or the cube root 3 stays the same. So my answer is 4 cube root 3. Now, I've had this question before. What if we did not realize that 64 was a multiple of 192? And let's say we chose 8 and 24. You can do that. You'll just have to use extra steps. So let me walk through the process of what would happen if I chose a smaller square root or cube root. So let's say I broke this up into 8 multiplied by 24. All right, I simplify 8. That equals 2. The cube root of 8 is 2. Multiplied by 3, the cube root of 24. Okay, cube root of 24, that is not simplified. So let me make my list for 24. I have 1 and 24, 2 and 12, 3 and 8. 8 is a cube root. So I'm going to break that apart again. So cube root of 24, that breaks up into cube root of 3 multiplied by the cube root of 8. Simplify that down. I get 3 cube root 3 multiplied by 2 times the cube root of 8 is 2. My final step is to multiply those 2 to give me 4 cube root 3. My same answer. So you can choose a different cube root that may not be the largest. However, you have to go through an additional step to simplify. So less work for you to choose the largest one. Okay. All right, that's all I have for you today for cube roots. Our other half of this is looking at square roots or cube roots with variables. What happens if my junk's got a letter in it? So here is our rule, which let me take a drink of coffee real quick. Given that I have a variable of a and it's raised to the m power. If my exponent there is a multiple of 2, I am going to divide that exponent value by 2. So, for example, I have k raised to the 10th power, and then I have that radical underneath it. I am going to divide that exponent by 2. So what's 10 divided by 2? Well, that's 5. I'm going to get rid of my radical, and my answer will be k raised to the 5th power. Isn't that nice and handy? So if you have a variable underneath your radical, and it is divisible by 2, so meaning it's even, then I'm going to just divide that exponent by 2 and get rid of that radical. However, let's say it's not a multiple of 2, and it's an odd number, okay? You're basically going to break up that radical so it is divisible by 2. So, for example, I have the square root of n raised to the 5th power. In order to make that value divisible by 2, I'm going to rewrite this as the square root of n raised to the 4th power multiplied by, multiplied by the square root of n. Remember, whenever I can break up my junk and multiply it together, but basically because of the product rule. So because of this rule, I break up my square root n to the 5th. I break it up into square root n raised to the 4th power multiplied by n. Now I can simplify that square root n to the 4th power because I can divide that by 2. So then my final simplified answer will be n raised to the 2nd power, because I divide that 4 by 2, square root n. So this is as simple as you can go. Let's look at some more examples. All right, I have the square root of 25 x raised to the 6th power y to the 12th power. I am going to try to identify those variables and see, okay, which of those is divisible by 2. Okay, I want to mention here, this whole big long thing, it may be easy for you to see on this problem. However, if you want to break it up, break it up. So I could rewrite this as square root of 25 multiplied by square root of x to the 6th power multiplied by square root y to the 12th power. All of that's the same. It's the same as rewritten up here. It's just broken up. I like to do that sometimes so I don't get confused. All right, the square root of 25 is 5. The square root of x to the 6th, I'm going to divide that exponent value by 2. So 6 divided by 2 gives me 3. And I am going to divide my y value, or that 12, by 2 as well. So I get 12 divided by 2 gives me 6. And there is my final answer. So the square root of 25, x to the 6th, y to the 12th, is 5x cubed, y to the 6th power. All right, example 11. This is one that you may want to break up just because square root of 40, that's not a perfect square. So you're going to have to break that apart and solve that. And then you'll also have to break apart the a to the 19th. So to start off, I'm going to break this up into square root of 40 multiplied by square root a to the 19th. Okay? Time to simplify square root 40. All right, I got to look and see what are my multiples of 40. So 1 and 40, 2 and 20, 4 and 10, 5 and 8, and that's it. Okay, looking at those listed there, which of those is a perfect square? Well, that would be 4. So square root of 40 is going to break up into square root 4 multiplied by square root 10 Square root of 4 is 2, which leaves me with just square root 10. Okay, I have that part simplified. Now to go look at my variable. Because remember, all of this is just multiplied by each other. So square root of a to the 19th, that is not an even exponent value, so I have to break it up. I'm going to break it up into a18 and square root a. So you basically just go one less value of this and pull out one variable. Square root of a to the 18th, that breaks up into a to the 9 value. So 18 divided by 2 gives me 9. Square root a. So now for my final answer, it's time to just combine my radicals and combine my coefficients. So my final answer is 2a to the 9th power square root of 10a. Not too shabby, right? Okay, last section. What do we do if we have a cube root with a variable? It's the same process before, except now we're looking at multiples of 3. So if I'm given the cube root of a to the raised to the n power, if my m is a multiple of 3, I'm going to divide that variable by 3. So for my example, I have the cube root of 64 m to the 9. So the cube root of 64, that gives me 4. Now looking at that variable, I'm going to divide that variable number by 3. So 9 by 3 gives me 3. So my answer is 4m raised to the 3rd power. Okay, if it's not a multiple of 3, you're going to break it apart so it is a variable of 3. Now, this may not be as simple as just knocking down one number, but you have to figure out what works for you so you can have a multiple of 3. So here I have the cube root of p to the 7. All right, I'm going to break that up into cube root p to the 6 and multiplied by cube root p, because then 6 divided by 3 gives me 2. So I have p squared square root of p. Okay, so with square roots, you're dividing by 2. Cube roots, you're dividing by 3. All right, let's look at one more problem before we get moving and grooving. I'm going to move this over to the side. Okay. I have negative 3 multiplied by the cube root of 40 W16. Okay, square root of 40 or cube root of 40 is not a perfect square. So, excuse me, I have to break it up. I make my list for my cube roots. And I have to figure out what's my highest perfect cube root value that's a multiple of 40 in order to break up that 40. This is also another problem that may be easier to rewrite. Oh man, and break up. So I'm going to break it up to negative 3 multiplied by cube root 40 multiplied by cube root of W16. Okay. I'm going to break up that cube root into 8 and 5 because 8 is a perfect cube root. Cube root of 40, that breaks up into the cube root of 5 multiplied by, actually I'm going to make this an 8, and the cube root of 5 and 8. Cube root of 8 simplifies down to 2, leaving me with 3 cube root 5. I'm going to combine my coefficients, so I have negative 6 cube root of 5. Okay, now time to come look at my variable. 16 is not divisible by 3. So I have to think, okay, below 16, what is the closest number that's divisible by 3? Well, that's 15. So I'm going to break up this variable into W15 multiplied by the cube root of W. All right, cube root of W, that breaks up because 15 divided by 3 is 5. So I have W5 multiplied by cube root of W. I'm going to drop that down one more value so it's even with, so it's even with my, my junk in the front. And now that I have my simplified versions of my cube roots, I can combine my coefficients, and I'm going to combine my junk in the trunk. So I have negative 6 W to the 5th power cube root of 5W. And there's my final answer. Okay. So cube roots are a little bit more challenging because it's not evident. A lot of us haven't memorized those perfect cubes. But once you have your list, you're able to see how it breaks apart and simplifies. That's all I have for you today. Let me know if you have any questions, guys.